Hi, today we'll discuss interfaces in Java. Interfaces are a second way to create polymorphic references in Java. We'll also discuss polymorphism and interfaces, as well as the comparable interface and the Iterator interface. A Java interface is a collection of constants and abstract methods utilized to reference a set of public methods. An abstract method is a method that does not have an implementation or a body of code written for it. The header of the method, including its parameter list, is followed by a semicolon, and it cannot be instantiated, be used to create an object. The example code in the other video that we'll do is of an interface called Encryption. It has two abstract methods, encrypt and decrypt. An abstract method can be followed by the Java reserved word abstract, but in interfaces it isn't always. Methods in interfaces have public visibility by default. A class implements an interface by supplying method implementations for every abstract method defined in the interface. The Encryptor class implements the Encryption interface. The Encryptor class implements the Encryption interface. An interface is a group of abstract methods and thus can't be instantiated or used to create objects. The Encryptor class implements the Encryption interface. A class that implements an interface utilizes the reserved word implements, followed by the interface name in the class header. If the class implements an interface, it has to supply a definition for all methods supplied in the interface. If not, the compiler will throw errors if any of the methods in the interface are not given a definition in the implementing class. In the Encryptor interface, the encrypt and decrypt methods are implemented, which meets the rules of the interface. Methods must be declared with the same signatures as their abstract equivalents in the interface. In the Encryptor class, the encryption is implemented utilizing a Caesar cipher that shifts the characters of the message a number of places on the Unicode character index. Another class that implements the encryption interface may use a completely different technique for an encryption. The Encryptor class also implements extra methods that are not part of the encryption interface. Is encrypted and toString that are not related to the interface. The interface asserts that the class implements certain methods, but it does not confine it from having more methods apart from the methods in the interface. It is normal for a class that implements an interface to have other methods. The main class with the main method creates some encryptor objects. An interface and its relation to a class can be displayed in a UML class diagram. An interface is like a class node, except the interface with the less than and greater than symbols is put above the interface name. A dotted arrow with a triangular arrowhead is linked from the class to the interface that it implements. Multiple classes can implement the same interface, supplying their own definitions for the methods. Example. The example can implement a class called passwords, or password, that too implements the encryption interface. An interface defines what methods are implemented, not how that they are implemented. A class implements many interfaces. A class can implement many interfaces. Thus, the class essentially provides an implementation for every method in all interfaces implemented. Class tree implements interface 1, interface 2, and interface 3. And in the interface, it implements all methods. In the class, it implements all the methods in the interface of all the interfaces, not just the abstract methods. So in class tree, we create a class tree that implements interface 1, interface 2, and interface 3. In class tree, it implements all of the methods in all interface 1, 2, and 3, not just abstract methods. An interface can contain constants defined utilizing the final modifier. When a class implements an interface, it gets access to all the constants defined in it. Now we'll discuss interface hierarchies. Interface hierarchies are the construct of inheritance and can be applied to interfaces and also to classes. One interface can be derivable from another interface and thus form an inheritance hierarchy, like a class hierarchy. Inheritance relationships among interfaces are shown in UML utilizing the same link, an arrow with an open arrowhead, that is utilized to display inheritance relations among classes. When a superclass interface is utilized to derive a child interface, the child acquires all abstract methods and constants of the superclass. Each class that implements the subclass interface has to implement all of the methods. There are no visibility problems when working with inheritance among interfaces because all members of an interface are public. Class hierarchies and interface hierarchies do not intersect. An interface can't be utilized to derive a class, and a class can't be utilized to derive an interface. A class and an interface interact only when a class is developed to implement a specific interface. Java interfaces, the comparable and iterator interfaces. The Java standard class library includes interfaces and classes. The comparable interface is defined in the java.lang package. The comparable interface includes only one method, Compareto, which takes an object as a parameter and returns an integer. The function of this interface is to supply a similar mechanism for comparing one object to another. One object invokes the method and passes the other object as a parameter. Example: if obj1.compareTo obj2 is less than 0, systems.out.println object1 is less than object2. The API Oracle documentation for the interface specifies that the integer that is returned from the Compareto method should be negative if obj1 is less than obj2, 0 if they are equal, and positive if obj1 is greater than obj2. The designer of each class develops what it means for one object of that class to be less than, equal to, or greater than another object. The string class has a Compareto method that functions in the same respect. The string class includes this method because it implements the comparable interface. The string class implementation of this method bases the comparison of the strings on lexicographic ordering defined by the Unicode character set, like the example code that we will do in the encryption example. It is based on the lexicographic Unicode character set, as all of the characters are shifted by a certain number of places. Comparable interface from the Java API Oracle docs. So there's a documentation. This is from the documentation, and it's exactly the same because it's open source. So I know we haven't discussed generic types yet, but we will in a future video that will be soon after the exceptions and input and output stream series. So what it's saying is interface comparable of generic type T, where the type parameter is T, represents the type of objects that this object may be compared to. So public interface comparable of type T. This interface imposes a total ordering on the objects of each class that implements it. The ordering, if referred to as the class's natural ordering, and the class's Compareto method is referred to as its natural comparison method. Method summary. Modifier and type, it's an int, it returns an int. And method and description, it's called the Compareto method, and it takes a generic type T, an object of generic type T. So instead of int O, it's TO. So T is a generic type. Compares this object with the specified object for order method detail. Compareto, Compareto, generic type T of O. Compares this object with the specified object for order. Returns a negative integer 0 or positive integer, as this object is less than, equal to, or greater than the specified object. The implementer must ensure SGN is the signum function that returns 0, negative 1, or positive 1. So x dot compared to y should return 0, negative 1, 0, or positive 1 should be equal to y dot compared to x, that should return negative 1, 0, or positive 1 for all x and y. It's kind of confusing, but it's just saying that it should be equal if you flip x and y. This implies that x compared to y must throw an exception if y dot compared to x throws an exception. There's some more rules here that are a little bit more confusing, and if you want you can read them. I'll just skip them for now. It is strongly recommended but not strictly required that x dot compared to y is equal to 0 is equal to x dot equals y. Generally speaking, any class that implements the comparable interface and violates this condition should clearly indicate this fact. So the SGN notation expression designates the mathematical signum function, which is defined to return 1 of 0, negative 1, or 1, according to whether the value of expression is negative, 0, or positive. Parameters. O is the object to be compared, returns a negative integer 0 or a positive integer, as this object is less than, equal to, or greater than the specified object. It throws a null pointer exception. We'll discuss that in the next series if the specified object is null, and it throws a class cast exception if the specified object type prevents it from being compared to this object. The Iterator Interface. The Iterator Interface is defined in the Java standard class library. It is utilized by a class that symbolizes a collection of objects, supplying a function to iterate through the collection one object at a time. An iterator can be processed utilizing a loop to process elements in the collection. Most iterators, including objects of the scanner class, are defined utilizing the Iterator Interface. The two primary methods in the Iterator Interface are hasNext, which returns a Boolean result, and next, which returns an object. No, none of the methods take any parameters. The hasNext method returns true if there are items left to process, and the next method returns the next object. It is up to the developer of the class that implements the Iterator Interface to determine the order of objects that will be sent by the next method The next method does not remove the object from the inherent collection. It returns a reference to it. The Iterator interface likewise includes a method called remove, which takes no parameters and has a void return type. A call to the remove method removes the object that was recently returned by the next method from the underlying collection. We will use the Iterator interface methods in another series of introduction to Java videos if you haven't used them already. Usually you can use them in a for loop or something and use them as conditions such as hasNext. So if scan dot hasNext, then you can iterate through, and you can also pass the next object in the collection. Polymorphism via interfaces. A class name can be utilized to declare the type of an object reference variable. An interface can also be utilized as a type of a reference variable. An interface reference variable can be utilized to refer to any object of any class that implements that interface. Example, public interface computer. So the interface computer has two abstract methods, public void view and public void display, which takes a parameter, string str. The interface name computer can now be used to declare an object reference variable. Example, computer current. The reference variable current can be utilized to refer to any object of any class that implements the computer interface. Example, if we define a class called laptop that implements the computer interface, we can assign a laptop object to a computer reference as follows. Current equals new laptop. Assignment is valid because a laptop is a computer and maintains an is-a relationship. The relationship between a child class and its interface is the same as the relationship between a child class and its parent class. It is an is-a relation. There's a typo here. It is an is-a relation, as the relation is formed via inheritance. And that relation defines the basis of polymorphism. The flexibleness of an interface reference permits us to develop polymorphic references. As discussed, utilizing inheritance, we can create a polymorphic reference that can refer to any of a set of objects if they are related by inheritance. Using interfaces, we can develop corresponding polymorphic references among objects that implement the same interface. Example, if we develop a class PC that also implements a computer interface, it can be assigned to a computer reference variable as well. The same reference variable can at one point to a laptop object and then later point to a PC object. Example, computer guest. Guest equals new laptop. Guest.view. Guest equals new PC. Guest.view. So here we're invoking the laptop version of guest, or the laptop version of view, and here we're invoking the PC version of view. So the abstract method was overridden, and then a new definition was created. And it's polymorphic because it's referring to a different message, the same object. The polymorphic object is referring to a different version of the view method. One in the parent and one in the child. In the first line of the code, the view method is called. It invokes the view method defined in the laptop class. The second time it is called, it invokes the view method of the PC class. As with polymorphic references via inheritance, it is not the type of reference that determines which method gets invoked. It is formed on the type of the object that the reference points to at the moment of invocation, which is at runtime. When we are utilizing an interface reference variable, we can invoke only the methods defined in the interface, even if the object it refers to has other methods to which it can respond. Example: if the laptop class also defined a public method called download, this code would generate a compile error, even if the object can contain the download method. Example: computer special equals new laptop special dot download. The problem is that the compiler asserts only that the object is a computer, and thus assures only that the object can respond to the view and display methods. Because the reference variable special could refer to a PC object which can't download, it does not allow the invocation. If we know in a specific that an invocation is valid. If we know specifically that an invocation is valid, we can cast the object into a suitable reference, thus the compiler will accept it. Example: we can cast laptop to special.download. Just as with polymorphic references formed on inheritance, we can use an interface name as the type of a method parameter. Any object of any class that implements the interface can be passed into the method. Example: takes a computer object as a parameter. Thus both a PC object and a laptop object can be passed into it in separate invocations. Public void sayIt takes a parameter computer of type computer, name current. So public void sayIt takes an object of type computer, name current, and here it calls current.view. Using a polymorphic reference as the formal parameter to a method is a powerful technique. It allows the method to control the types of parameters passed into it, yet it gives the flexibility to accept arguments of various types. A parameter to a method can be polymorphic, which gives the method flexible control of its arguments. An interface reference can refer to any object of any class that implements that interface.